neutrons. Dear students, after that we just switch over to few concepts like isotopes, isobars, isotones, isoelectronic species, and isosteric species and isostructural species. So dear students, I hope you have written every part here. Okay dear students, now define the following. First is what is that? Isotopes. What do you mean the term isotopes? Iso means same and topes means number. Atoms of an element having same atomic number but different what? Mass number, not atomic mass. Why? Because of mass number is sum of the protons and neutrons and they are never in fraction. So don't use the word atomic mass. Always you are mistaken that the atomic mass. No, it is known as the mass number. That is sum of protons and neutrons and these are not found in the fraction. So my dear students, here same atomic number of lot of isotopes are given. For example, hydrogen has 3 isotopes. You can see 1H1, 1H2 and 1H3. Protium, deuterium and tritium. Right? Many of you may be knowing chlorine has 2 isotopes. Chlorine 35, chlorine 37, 17 and 17. What is same? Atomic number same, but mass numbers are different. Now tell me about the isobars. Same mass number, but different atomic number. Right? For example, very common example you may find in book: argon, potassium and calcium. You can take 40, 40 and 40, 18, 19 and 20. What is similarity here? 40, 40 and 40. That means, dear students, here it is 40, 40 and 40. Mass number remains same, but atomic numbers are different. Now, what is the isotones? What do you mean the term isotones? That is the same number of neutron but different atomic number and mass number. For example, you can say, dear students, silicon, phosphorus and sulfur, 14, 15 and 16, 30, 31 and 32. So dear students, here tell me electrons 14, proton 14, but what neutron? 30 minus 40, 16, right? So here in case of the proton, so tell me electrons 15, proton 15 and neutron once again 16. Similarly in case of the sulfur, my dear students, it is 16, 16 and 16. So what is common in all these chemical species? Common is that the number of neutrons and neutrons. So these are, isotones. Is it clear to everyone? Did you complete all that? Isotopes, isobars and isotones. So after that we take isoelectronic species. Isoelectronic species. Those chemical species having same number of what? Electrons. We have done in mole concept. There you can write here sodium 1 positive, magnesium 2 positive, aluminum 3 positive, neon, nitrogen 3 negative, oxygen 2 negative, and fluorine 1 negative. Right. Calculate the electrons here. Whatever the atomic number, in case of the minus, we have to add, in case of the plus, we have to subtract. Electrons 11 minus 1, 10, 10, 10. Neon is an inert gas. Here 7 plus 3, 10. 2, 8 plus 2, 10. 9 plus 1, 10. So these all are isoelectronic species having the same number of, electrons. For example, you can say phosphorus 3 negative, sulfur 2 negative, and chlorine 1 negative. These are isoelectronic with which inert gas? Argon, right? Because 15 plus 3, 18, 18 and 18. Just like this. You can say cesium 1 positive is equal to what is there? Isoelectronic with xenon, because atomic number of cesium 55. Similarly here, radon 86 is the isoelectronic of what is this? Francium. It is positive 87. So the way you can solve many more questions based on isoelectronic species. Dear students, next is that is isosteric species. Where are this part here? It's all right. Okay. So just go for isosteric species. A pair of chemical species contains same number of atoms and electrons. Anybody tell me the example of the isosteric? A pair of chemical species, a pair of chemical substances which possess the same number of atoms as well as what? Electrons. For example, I give you CO2 and N2O, carbon dioxide and nitrous oxide. Remember, in law of multiple proportion, I have given you the oxides, so one of the oxides of the nitrogen. My dear students, here, how many atoms are there? Now tell me, that means ki 1 plus 2, 1 plus 2, how many atoms? 3, and here it is the 3. But how many electrons are there? Carbon atomic number 6 plus 8 into 2, 16 plus 6, how many electrons are there? 22 electrons. So it's supposed to be same this side also, right? 7 into 2 plus 8, 22 electrons. I'll give you the other example. CO and N2. Right now, how many atoms are there? Atoms are 2. One is the carbon and the oxygen. 2 atoms, carbon monoxide. Here 2 atoms. But what about the electrons? 6 plus 8, 14. 7 into 2, 14. Dear students, you can take other example. Cyanide ion and N2. Dear students, is it the isosteric species? Yes, of course, because of 6 plus 7 plus 1. How many electrons? 14. And here 14. How many atoms? 2 atoms, and here again the 2 atoms. So the way you can explain isotopes, isobars, isotones, isoelectronics, isosteric, and one is isostructural species. Anybody can tell me the example of isostructural, although that is not in your syllabus, but it is very small part. It's my pleasure to explain you isostructural species here. So dear students, isostructural structural species. Same structure near about, same electrons and same atoms. Structure, electrons and atoms supposed to be same. One common example here I give you, benzene, and other is the borazole. Borazole is called as inorganic benzene. It is asked in the entrance paper that everybody knows organic benzene C6H6, but very few of us know about borazole or borazine, that is the inorganic benzene. It is B3N3H6 and benzene is the organic benzene C6H6. Now tell me how many electrons? 6 into 6 plus 1 into 6. Total electrons 42. And anybody tell me how many atoms are there? 6 plus 6. What is that? 12 atoms. I made it clear? Now in case of this boron, hydrogen, helium, lithium, beryllium and boron, 5 atomic number. So 5 into 3, nitrogen 7 into 3 plus 1 into 6. Dear students, it becomes 42 electrons. Then how many atoms? 3 plus 3 plus 6, 12 atoms. So do you agree that these are the isostructural as well as isosteric, but isosteric as well as isoelectronic? But how do they have the isostructural form? Just you go it like benzene is like this. It is alternate pi bond in the benzene. It can undergo delocalization here. Pi bond undergo delocalization. So benzene is C6H6. Ultimately you can write wavefall of the pi bond. It is the benzene. In case of the borazole, boron, nitrogen, boron, nitrogen, boron and nitrogen. Dear students, it is B, B and B. Boron, right, and then hydrogen is 1H, 2H, 3H, 4H, 5H and what else? Although nitrogen atomic number 7, in the last shell there are 5 electrons. 3 electrons are involved in bonding, 1 lone pair is still left over on nitrogen. So dear students, here tell me, here 1 lone pair, here lone pair and here lone pair. So this lone pair shifting to this side, this lone pair is shifting to this side and this lone pair is shifting to this side. What about the another resonance? Boron, nitrogen, boron, nitrogen and it is the boron. So dear students, here, so again it is hydrogen is still at its own platform, at its own position. Every atom, because resonance you will study in chemical bonding, the phenomena in which molecules may be exhibited into or more structures in which they differ in their distribution of the electrons but not the atom. More the number of resonating structures, more the stability, as such more the exchange of energy. My dear children, here it is the positive charge, it is the positive nitrogen. Anybody tell me why it is positive charge? Because it has provided lone pair to the other portion of the atom. Boron since gain the electron, negative, boron is the negative, minus plus neutralize to each other. But one difference between benzene and borazine is that benzene has complete delocalization, but here it has, you can say, partial delocalization. Only the difference. Otherwise you can take both in the same platform. What is that? Benzene and borazole are the common examples of the isoelectronics, isostructural as well as isosteric. So I hope I have started the beginning part of the atomic structure or structure of the atom by taking the discovery of electrons, protons, neutrons, Goldstein, J.J. Thomson and Jens Chadwick, by taking the credit of the radioactivity, properties of the cathode and the anode rays, how to express, the electrons, protons and neutrons, and the terminologies are quite often you will find having several and multiple applications like isotopes, isobars, isotones, isoelectronics, isostructural as well as, dear students, isosteric species. Now, in my next class, we will discuss the next part of atomic structure, and this is my request to prepare notes systematically, and from time to time I do provide you good number of lectures so that your concept will try to improve and enhance your concept. Thank you very much and have a nice day everyone. God bless you. Thank you.